And welcome to this new video in which I'm going to show you how to run the ARDL model in EViews. So ARDL model is generally run when variables are integrated of order 0 and 1. So when variables are integrated of order 0 and 1, ARDL model is very appropriate. Even though we can run ARDL when variables are all integrated of order 1, generally the Johnson cointegration is performed in order to see if whether or not there exists a long-run relationship or the Johnson cointegration among variables in order to run the error correction model. So but in the case in which we have variable that integrated of order 0 and 1, it's not possible to run the Johnson cointegration, but we can run the bound cointegration test that has been developed by Toda Yamamoto. So in this video we'll show you how to perform the ARDL model as well as bound tests in order to go to long run cointegration form of ARDL model. So if the first time you are watching one of my videos, do not hesitate to subscribe to the YouTube channel and activate the notification bell in order not to lose the next video. So as we said, this video we have variable that are integrated of order 0 and 1, and we will check it out. So I have macroeconomic variable like GDP. So I have a log GDP that I have generated here. So you can test for unit rule, for example, for a variable XRT, that is exchange rate. So in our model we are going to see, for example, the impact of exchange rate on economic growth. So to run the unit growth test, you just need to go in view, unit growth test, level. So we have augmented decay Fuller test by default. We can run Liperon, KPSS, and so on. So we will keep augmented decay Fuller test, that is by default value. Click on OK. We can see that p-value is higher than 5%. So we the variable exchange rate is not stationary. We look at stationary at first difference, and you can see that our variable is stationary at the difference. We can also look at variable at inflation, unit growth test level here. So you can see that our variable inflation is stationary because the p-value is less than 5%. So you can also now notice that there are variables that are integrated of order 0 and variables that are integrated of order 1, so that we can run our ARDL model. Our dependent variable will be the log GDP. So we click on quick estimate equation, log GDP. Independent variable, we have exchange rate, foreign direct investment, FDI, foreign direct investment. We have variable government spending, inflation, unemployment. So most of the time in ARDL there are problem of collinearity when we and it's generally due to the fact that we put so many lag in our model. So to run our ARDL, we'll select ARDL here in method, ARDL autoregressive distributed lag model. So as I was saying, most of the time ARDL model we are not able to perform ARDL due to the number of lags. So we have here for the dependent variable, default value is 4 lags, and regressor are 4 lags. So that's the maximum lag that we can have in our model. The software EViews will, among all possible model, choose the optimal lag for any variable that will not be more than 4. Generally, if I will copy first of all my equation, if I run the model, we can see this message like singular matrix, meaning that we have put a lot of lags in our model. We'll use lag in our equation in order to maybe obtain a good estimation. So quick estimate equation, method ARDL, we'll put here first of all 1 lag, for example, and you can see that the result have been computed. We can also choose maximum lag 2 to see if the method has been executed. Estimation, you can go up to 3. Singular matrix, meaning that we should keep it at 2 lags. So we can see that our ARDL model has been computed, and we can see the significance of any variable GDP that have many lags. So we can also reduce as well the number of lag for GDP. So we have here this relationship, so we can go at 3. We can estimate all other model that we want. We can focus on this new model that we have estimated and search if whether or not there exists a long-run relationship among our variable by running the bound test. So to run the bound cointegration test, we need to just need to go in view, coefficient diagnostic, and then select long-run form and bound test. So click on OK, and we go down into this table, and you can see that our Fisher statistic for the bound test is 21. That is higher than all critical value at 10, 5, 2.5 or 1% level. So we can say that there exists a long-run relationship among our variable. And here, this equation in the top of that is the long run relationship between log GDP, exchange rate, foreign direct investment. And we can see that exchange rate have a positive impact, even though the impact is not significant at long run on the GDP. Foreign direct investment have a positive and significant impact on the GDP. Unemployment have a long run negative impact on the GDP, meaning that we need to put the policy in order to promote employment so that can produce more in the economy. So here is the long run relationship, and the bound test say that there is a long run relationship. And finally, what we need to do is to run cointegration from after testing for a cointegration bound cointegration test. We can go on view coefficient diagnostics and go to long error correction form. Here is the error correction form of our model. Error correction term in negative and significant, meaning that there exists a error correction mechanism that correct any disequilibrium in our economy. So you can see that foreign direct investment have a positive impact in the short run, as well as exchange rate that have negative impact in the short run. Here's the error correction form is the short run equation of our model. So we can go and to look at diagnostic tests in like normality, error autocorrelation in view, residual diagnostics, histogram normality. We have you can see that our error term are not normally distributed, meaning that we should try maybe to change specification or adding any other variable in order to have a good equation. So that's it for this video. We'll see you very soon.